All right, so this is going to be the second part of kind of my explanation here for the acceleration, speed, and velocity practice worksheet here. So we just finished off with that average velocity question. Now we're going to move on to acceleration. So you can kind of see the different options for the equation here. Hopefully some of you remember this from algebra, but you're just going to be kind of shifting stuff around depending on the information that you have. So in this first equation, this is how we get acceleration. So if we have the final velocity, initial velocity, and the time, then we would be able to figure out the acceleration. But if, say, we needed to know the time frame, this is how the equation would be set up, and same thing for final velocity in there. So this first question for practice, we are going to look at, so a roller coaster car rapidly picks up speed as it rolls down a hill. As it starts down the slope, its speed is 4 meters per second, but 3 seconds later at the bottom of the slope, it's 22 meters per second. So we're going to look at what the average velocity is here. So if we take, again, that final velocity we have there as 22 meters per second, and then our initial, which is 4 meters per second. And then we are going to divide that whole thing by 3 seconds. So then we're going to take that divided by 3 seconds. And then I already have that answer up here, but 22 meters per second minus 4 is going to be 18. So it'll be 18 divided by 3, which is how we get this 6 meters per second squared. So again, like I mentioned, the metrics do matter here. So again, this is 6 meters per second squared. We can probably get more into that later, but just for your purpose, acceleration is always going to be some distance divided by a time frame squared. All right, so the second problem here, if a Ferrari with an initial velocity of 10 meters per second accelerates at a rate of 50 meters per second squared for 3 seconds, what will the final velocity be? So again, if we look at our equation here, final velocity we can find by taking the acceleration, which was 50 meters per second squared, and then multiplying it by the time, which is in this scenario 3 seconds. And then we are going to add the initial velocity. So the initial velocity is 10 meters per second. And then if we kind of do the math on that, it'll come out, 150 meters per second plus 10 meters per second. So this should be 150. And then obviously adding those two things up would get our final velocity at 160. And then this example would be what happens if we are going, if we are slowing down or decelerating. So we're going to take our final velocity, which in this scenario is going to be 0. Right. So we have 0 meters per second, because if you read the problem here, it says and come to a complete stop. So 0 meters per second minus 30 meters per second, because that's how fast we were going initially. And then we are going to divide this by the acceleration. So that acceleration there is going to actually be a negative, so it's negative 4.0 meters per second squared. So once we kind of do the math here, we get negative 30 meters per second divided by negative 4. So those negatives would cancel out, and it'd be 30 divided by 4, which would get us 7.5 seconds for our answer there. So again, just based on what you are trying to find, you're going to kind of switch around the equation as needed. And then this part is where you're going to get started on your own. So these equations over here on the side are going to help you to find distance. It's speed times time. Time is distance divided by speed, and then speed is distance divided by time. So you're going to go through these next about 15 problems on your own. Obviously,